Hey everybody, I'm Shashank at Modular and welcome to the Modular Community Livestream. This is our fourth edition and the theme of today's livestream is the new release, which is Mojo SDK version 0.5, but we have a couple of other updates that we want to share with you. So let's start with a quick round of introductions. For some of you who've been watching all the live streams, the faces may look familiar today. For those who are joining in for the first time, welcome. Thank you for spending your time with us. Again, I'm Shashank. I'm a developer advocate at Modular. And who wants to go next?
Hey, yeah, I'm Jack. I'm a developer advocate as well at Modular.
Awesome.
Hi, my name is Abdul. I lead the kernel team here at Modular.
And I'm Jeff. I work on Mojo here at Modular.
Awesome. So the purpose of these live streams is really Q&A. So we do have stuff to share and we will, but the whole point of the live stream is for you to ask us questions about either the features that are new in the recent release or other questions you have about Mojo. You have experts here, Abdul and Jeff, who work on Mojo, build Mojo features. So please feel free to ask questions and so let's get started. Before we jump into the features of Mojo SDK 0.5, I want to highlight a couple of things. One, we recently announced ModCon, our first ever conference, and this is going to be on December 4th here in California, Bay Area, and in San Francisco. And we have a new web page. If you head over to modular.com/ModCon, you should see the page with information about the conference, and we have a very exciting lineup of speakers. Folks from our own team who are building Mojo and the engine, but also some exciting speakers from across the industry. Now, the registration is open. If you want to attend, and you should, there's a lot of exciting things at the conference. Go ahead and click register now. If you register before Monday, there's early bird pricing. After that, the prices go up a little. We have a few more seats left. Please feel free to register. There's competitions and very exciting announcements and all that. You'll get to see it firsthand. Okay. Awesome. So that's ModCon. And Jack, do you want to talk about the some updates about ModCon and also about the newsletter?
Yeah, sure. So this is our weekly newsletter that goes out. So in this, I just highlight anything that's going on in Modular. So we have the ModCon announcement there. And then below that, there'll be any kind of blog posts or any videos that we release, I put in there. And then even further down, I put in community projects. So any cool community projects that get created, I chuck them in there. So if you're working on anything, go to the Discord and put it in there, and I'll highlight it here. And just one other thing as well is we're going to be hosting a competition for ModCon. So that'll be any project that you got on Mojo. It can be anything at all. We'll select the top sort of 5 to 6 projects, and then they'll get presented on stage, and we'll judge them, and there'll be a winner, and you'll get prizes like swag, and you'll be able to present a blog post on our website and all kinds of cool things. So yeah, if you're working on anything cool, keep an eye out, and we'll announce soon how you can submit your project.
That's awesome. I guess the key takeaway is head over to Discord and let us know if you're working on cool things. Unfortunately, I can't participate, right, Jack? I can't participate in the Mojo competition.
We might be able to make an exception if it's good enough.
I'm sure there's far more talented folks out there. So yeah, please register for ModCon if you want to attend. It'll be fun. It'll be a ton of fun. Okay, so that was the quick updates. I think it's a good time to head over to the recent release and features in the recent release. If you haven't already seen the changelog has a list of features that are new, what's changed and fixed. So what I want to do through the next 10-15 minutes or so is go through some of these features in examples, and we'll walk through it, and feel free to ask questions about these features, and we'll try to answer them. I have some samples. I know Jack has a few different examples too. So let's jump right in. So welcome, and please keep posting your questions on the stream. So what we'll do is every time we go through a section, we'll pause, we'll take some questions, answer them, and move on to the next one. Okay, so what's new in Mojo SDK version 0.5? Now, Mojo is a young language. It's rapidly evolving, so a lot of things that you might expect in Python, you'll start seeing them in Mojo. So one of the first features we have is keyword parameters. Now, if you used Mojo in the past, you couldn't do stuff like this. You could do keyword arguments, but you couldn't specify keyword parameters. Now, a quick refresher is parameters in Mojo are compile time parameters where arguments are for runtime, right? So here's a quick example. What I'll do is just go ahead and run it. This is a structure in Mojo, and it's called square matrix. So in summary, what it does is it defines square matrix. Very simple, right? Square matrix. And I don't implement this from scratch. I'm just using the tensor type, which is in the Mojo standard library. And I define initialization function, get function, and a print function. And I can go run. I can go, instantiate this and create a square matrix. Simple, straightforward. Now you see that I created a square matrix, but I didn't specify parameters or I didn't specify arguments because I have defaults here. By default, it is float type 32. Default, it is dimension 4. And by default, the argument value is 5, which is what you would see here. Float 32, the shape is 4 by 4 because it's a square matrix. And all the values in there are 5 because that's the defaults. So this is the new thing that you can do in this release. Now, of course, I can specify keyword arguments, but I can also specify positional parameters. This way, I change it to float 64, right, instead of the default 32. I can also specify, of course, keyword and positional stuff. And I fill it with ones instead of the default 5, and you see this. And finally, like, you can provide everything as keyword arguments and parameters, and you do this. Okay, so this is a new feature. This is again highlighted in the changelog, and here's a simple example. At the end of this live stream, I'll share this notebook with you so you can play around with it as well. There's also keyword arguments in get item. So if you do things like access elements of a tensor, of an array, like what I do here, I define a get item. So let me go ahead and run this. I create this and I access specific values, X and Y, and you can provide this as keyword arguments, and you'll see this defined here, the get item, right? So if you're creating your own structs, then this is pretty cool. It makes code more readable, and you can use them. Okay, so that's the first feature. Let's see if there are any questions. There are a couple of other interesting things that I'll go through next.
Well, I want to just interject a little bit.
Yeah.
One of the features that you missed is the ability to print a tensor.
Yeah.
So,
I thank you, Abdul. Thank you, Abdul. I did miss. So thank you. Careful-eyed viewers will also notice that I created a print function and I print a tensor. Now mat is a tensor type. This was not possible in the previous release, as Abdul pointed out, and I wanted to, and I missed that. So that is why when I say square matrix.print, it prints the tensor. Thanks, Abdul. So that's a new feature too, which was one of my intentions to show, and I didn't call it out. Awesome. Let's see if there are any questions, and then we'll move on to the next one. All right, questions. Okay, let's go through some of these. Please release debugging support. Is that I don't know. Do we have debugging support, or don't we? I don't know, anyone wants
If you keep an eye out during ModCon, we might have some announcements around that. So yeah, check it out at ModCon coming soon.
Static.
Okay, Jack, your mic is creating static. Okay, awesome. So basically, Jack said keep an eye out, and we might have some exciting things in ModCon. Of course, you have to attend if you want to see what's there. Awesome. Any other questions here? About Python interop, I think. Hi, I'm new to Modular and Mojo. From what I understand, you can import Python packages and use them as I would if I were coding in Python. I have a custom Conda environment that includes a proprietary Python package that I wrote. Would I be able to code in Mojo while working in this Conda environment? Partially, yes, but I would say you can import your package into Mojo. You can set the path. The Jack has a very nice blog post where he shows you how to use custom Conda environment. I wouldn't call it work inside the Conda environment, but yes, you can import packages. Let me pull up the blog post and I'll show you which one, and then you can go read it. So this is called Python using Mojo with Python. So this is a blog post that Jack wrote, has all the nuances, all the things that you need in order to call Python functions. He has some interesting examples with using matplotlib and numpy, but it could very well be your own custom package. I think there's also a custom package example. Okay, so the answer is yes. The short answer is yes. Any other questions here? When will you be supported? Lifetime? I don't know.
After traits.
Okay. I hope that was explanatory.
For
okay.
traits,
Traits.
there may also be ModCon announcements.
Awesome. Yeah, ModCon. I think.
Yeah, it's gonna be a smash hit event.
Here's a question. I think the answer is yes. Will there be complex type support for tensors and math? Will there be complex type support for tensors and math? I know there's like some complex support, right? I think there's
so there is complex support, but it's not on the tensor type. I think we could definitely add that. Please file an issue, and then we'll look and see of adding that. Also, like if you have a motivating use case, that would be super great as well.
Yeah, I would say echo what Abdul said. Please file a issue here and a good use case, so we can help prioritize those features, right? So yeah, so please do that if you have a feature request. Awesome. Should we move on with a couple of other questions? Okay, traits. So apparently traits is a winner, Jeff. A bunch of traits in the comments. That's awesome. Okay, let's go. Let's move on to the next example. Okay, so we spoke about keyword parameters and get item. So now we have automatic parameterization of function. I'll try my best to explain how I understood it, and of course we have Jeff and Abdul who can add more color. Now, I use the same square matrix I created. Let me run this cell in Jupyter, and I'll talk through what's going on. So we use the same square matrix. So I create this, instantiate this square matrix with value 5. And then I have a function here called multiply. So what it does is multiplies all the elements of the matrix with 10. Or this could be, I don't know, 100, right? And then you get 500. Okay. Now, if you take a closer look at this function takes in square matrix and a value of SIMD type and returns a tensor. And this function basically goes through all the elements in a vectorized way and does the multiplication for you. Now, square matrix has parameters. The default parameters that I don't specify here. Normally, in the earlier version, you would need to pass those compile time parameters to the function. Here it automatically gets added to this function, and the interesting thing is you can access those using the input parameters. So sm is a square matrix. Now I can do sm.dtype. I can also access sm.dtype and create these access those compile time parameters directly. If I were to run this in the earlier version, I would have to explicitly do that and specify. But this new feature makes your code look a lot cleaner, and you can access all the compile time parameters through the variable name. So that's the new feature. Anything else we want to add there?
Well, really,
Abdul,
what
just
this
beyond
is,
this?
really what this is the start of being able to access static properties of
Hmm.
dynamic values in parameter contexts. So like the natural next thing to be able to write here is like type of SM, right?
Mm.
It's not, don't have that yet, but like that's the natural next thing to do. If people who are familiar with C++, you can do like decal type and then this huge expression starting with a decal val or a dynamic value, and you get out a type. So that's something that we'd really like to support. I think it'd make the meta programming in the language much better.
Yeah. The
Yeah.
other thing I would add is, like you have mul SMD type SIMD width in your vectorize. You could just call mul. You don't have to. There's a lot of inference that happens.
Oh, this one. You can completely skip this and
Yeah. So
do
you
you want
can
me to try
remove
this
the-
live? Do you want me to try
Yeah.
this live?
You
Okay.
should try it.
Let's do it. Let's do it. That's why we have a live stream. Okay.
No. Okay.
Okay.
It should work. We should file an issue.
Okay. See, that's why we have the live stream. Okay. That's my job. I'll go file an issue for that. But yeah, as you try this, folks, if you have, if you run into things that don't behave like you expect them to, please let us know. Mojo is constantly improving. Okay, so that's the automatic parameterization, and I think my key takeaway is that code looks cleaner. I'm constantly looking for what makes code look cleaner, succinct, especially when I'm writing examples. I'm like, how can I show this simply? All right. Any questions here? Awesome. We'll see. Will this notebook file be uploaded to GitHub? Yes. It's not yet there because I just finished writing it today morning. But where you will find it is on GitHub. Here. GitHub Modular ML Mojo. So if you head out to Mojo under examples, we'll share it in in blocks and videos hopefully. But we'll put it in the description of the video so you'll know where it is. Awesome. And okay, when the same person who asked for lifetime, I think. When will you be supported? Class. What on? Is that the right answer?
No. Okay, so if I had to like, talk a little bit about programming languages and stuff, you can think of traits. Traits are static, but meaning that you statically know the functions and properties of a particular type. Say, my printable always implements dunder repr. Now, the natural next question you could ask there is like, what does a dynamic representation of a trait look like? So instead of saying I have a type T that is an instance of printable, you have a dynamic value X that is a printable. So the runtime representation of that actually, you need to have a vtable that contains a function pointer to the print method. So in Swift, that's called existentials. I believe in Java, they're called interfaces. So they're called different things in many different languages. But when you have traits, we have the static representation of something. When you then build a dynamic representation of it, well, if you have a vtable, you're now only a couple steps away from having classes. So that's part of like, we have the spectrum of dynamism in Mojo. There's the wholly static world on one side, and you have the really, really dynamic world on the other side. Traits can be the beginning of moving towards like this kind of restricted dynamism where you get vtable based classes and inheritance. So we're getting there. It's the bricks are being laid, and it's the next big brick is traits. And on top of that, we start moving into the dynamic world and so on and so forth.
Yeah, building a language is hard, right?
Well, the good news is that a lot of other languages have classes, so it's not a new thing.
Right.
But we're building it with new technology, so the implementation challenges are a little different every time.
Awesome. Someone's like really living in the future. When will Mojo 1.0 be available? Slowly, steadily. We are in 0.5. I think we'll increment slowly, improve it in the future. I think is the best answer for that. But you can learn about all the new stuff at ModCon if you tune in. Please register. A question about, again, forward-looking one. People have forward-looking questions here on the stream. How will code work with GPU CPU? Can you have some parts running on CPU and other parts running on GPU? Well, we don't have GPU support today. I don't know if you want to share anything more beyond that.
Again, stay tuned for ModCon. A lot of interesting things will be discussed. And we're also going to have a dedicated session talking about the vision. What does the next 6 months, 1 year, 5-year roadmap look like?
And on that will definitely be like what does a 1.0, what does a Mojo 1.0 look like? What does that mean? To some degree, we don't really know yet, but that's definitely something that we'll have to figure out what the future of the language is going to be.
Awesome. There's one last question. We'll move on to the next section. How are you thinking about handling open file RB, since I would assume the return type won't be a string? We have some file capabilities today, right?
So that part is a binary. So there is a way to open a file. If it's not, actually go to path.
Path? Okay.
Yeah, pathlib path. Okay. So the next release of Mojo will have the ability to read a file in binary form, and you're not returning a string; you're returning a buffer of of bytes, right? So that would allow you to do that. So read right now, read and write are kind of returning strings at this moment, but I mean, Lucas is correct that they're null terminated. So if I have a 0 in one of the bytes, then the string is like, up to the first 0. So we know that, and we added another method.
Cool. I'll do this one last question before I proceed. Python in Mojo is good. What are the plans for Mojo in Python? This is a question we've received quite often. What we have today is in Mojo, you have Python interop. You can actually import Python packages and call Python functions, but there isn't a way to call Python Mojo from Python. Although there are some community built hacks that allow you to
someone
do it.
figured out that inside a Mojo package is a binary, is a static archive, and they managed to figure out the symbols and rip them out and call them from Python. So no surprise there. There's a really
Don't
smart
run it in
tool out there.
production. Don't run any of this.
Please don't do that. So we know that this is like possibly, after macOS support and getting, can I run Mojo on my system and all that stuff? Like one of the biggest requests for Mojo. And part of this is like, as soon as we do this, provide this ability, people are going to use it, right? Because that's the sell of the language, is accelerating Python code. And obviously, like having the driver be Mojo, where you call into your Python package, is not quite the same as I have this massive Python code base. I want to call into Mojo. So the challenge there is that will be something that would have to last. That'll have to be stable because people will depend on it. So please don't depend on ripping static archives out of the Mojo package format. But something like that will definitely come. But it's not really clear when that will be because it has to be done properly. There's also thinking about how are we going to ship it? How are we going to integrate this with Python packaging? Are you going to be able to pip install a Mojo package? Mojo doesn't even have a package manager today. So there's lots of questions to be answered here on how we can deliver like a production quality experience of integrating Mojo and Python.
Yeah, the other thing I would say is there's a ton of Python versions, which makes some of this as well like hard, and as well as you end up with these OS as well. Like every OS has a different way to load libraries and integrate them. So there's another question to do that. But yeah, you should definitely upvote it as a few arrows on the screen, and then we'll definitely tackle that.
In general, this works as in, please voice out your request. If there's an existing issue, upvote or create a new one. If you notice, like Mac support was like the highest voted thing, and that was what came out next, right? So it's a good way to provide feedback so we can, improve. Awesome. So let's move to the next one and take more questions. Speaking of file load and save, I think this one will be interesting. So tensors, which is the container for n-dimensional tensors in Mojo standard library, has a couple of enhancements, namely file read and file write. So let me show it to you in the documentation, and then we'll run the example. So if you head out to tensor, there is from file and to file. So those are the two new functions. Lets you write tensor into a file. So what I do here is take the same square matrix struct that I created. I add a couple of things. One, I'll also highlight the string features. So string also has 3 new features. It adds count, replace, and find. So these are also new to the string type, and then there's a tensor file read and file write type. So what I do is I add 3 new functions here. So I create again, these are just for illustration. I'm not saying these are how you should use it. I try to shoehorn these features just to illustrate them. So let me run this, and I'll show you what this looks like. So you can save. So the save function basically takes in a file name. I call it saved matrix, and then it prepares it. By prepare it, what I do is I check if there is an extension. If not, I add a .data extension. I then just to illustrate replace, if I take the dot and replace it with the specification of the tensor type, and if it's not a path, if it's just a file name, I add the current directory path. So that's prepare file name. It illustrates the 3 new features in string, and then you can run to file path. And what this does is saves it. So if I run this, what you should see is this is the matrix, and the file is saved to disk here. So you should see this here. Okay, so it saved the data there. Now I can go read it again. So I have a static method in there. It doesn't have to be, it could be a separate function. I just put it there. So I can go run this. So what it does, it loads the matrix. Now the caveat here is that the data gets saved without preserving the shape of the tensor today. So what it does is it'll save all the information in the tensor, but you lose the shape of the tensor. So what I do is actually reshape it back, and I create a new tensor with the dimensions that I want, and then I copy the data onto that. But that's what the feature is today.
And
Hopefully
this will be fixed in the next release. So like, what Shashank mentioned is a weakness that we overlooked, and he was a good citizen, filed a bug report, and then we're fixing it.
Awesome. That's how we improve, right? Small steps. And but you can still use it. It's just that there's extra steps here, and if it's a large enough matrix, maybe it's not efficient to copy data, but you could use it today. You can use it. So which is why I saved the the dimensions and the type into the file name, so you can use it. But again, the whole point of this to illustrate that you can now manipulate strings a little better with count, replace, and find. You can save to file, and you can read from file. These are tensors, but I use this in this custom struct. Okay, so that's the tensor and string enhancements. So let's take a look at some questions before we move on to the last bit. Okay. Oh, wow. Questions are really ramping up here. At a high level, will the exact same code in Python run faster naturally in Mojo without any tweaks? I think we've sort of answered this in the past. All of the syntax isn't supported in Mojo, but in some examples, we show that it does run faster. I think, I don't know if Jeff or Abdul want to add more color to that.
I'll give the short. Okay, Abdul, give the answer.
Oh, sorry. So some examples. I mean, not everything is. So there's two sides of the question. Eventually, yes, we should be able to copy and paste code, and it should just work in Mojo, and you get perf improvements. Today,
automatically translate code. There's there's like keyword differences and it's very, very minor syntactic differences.
Yeah, but I mean, even without like introducing var and let and all that, you should get speed up. So I'd recommend looking at the first part of the matmul code. I forget what the numbers were, but like we just copied the Python code and pasted it in Mojo. Not this one, but in the matrix, in the Mandelbrot blog posts.
Oh, Mandelbrot. Okay.
I think
we also do this in the notebook, though.
okay. Yeah.
We
So
copy paste
I think it was like
this code. I think we just copy pasted into this is Python stuff, and then importing Python to Mojo. Now this is like Mojo untyped. We say untyped because you can add types.
Yeah, but what is the speed? I guess I forget what the perf was, 5x or 50x.
I don't know if we published the numbers here, but I could ad hoc try to run this.
No, I mean it's published in the Mandelbrot blog post. Let me find. It's
let's pull up the blog.
Either 5x or 50x. I forget what the number is, but 5x is always great.
And the first one, first blog post.
Yeah, the first one. Yeah.
Okay, let's go to part 1. Part 1 is here.
Yeah. So scroll down. First graph, I guess.
First graph.
So, it's yeah, so it's 46x. So it's there's a huge benefit here. I just copied and pasted the code. Yeah, but again, it's a question of
so here there's no code changes, right?
Yeah, there's no code change. I just took the file and then just renamed .py to .mojo essentially.
And then you should, I mean, for all you viewers, I think you should read this series because this part 1. I mean, you may not be using Mandelbrot, but the fact that I learned a lot from these series from Abdul because he progressively adds optimizations. Starts with Python, like vectorize, and then parallelize, and using larger vectorization lens. Just like you should read it because you can see all the optimizations that you can apply to your own programs. So highly recommend that. Okay, so if we feel like we answered that, let's see if there are other okay. Oh man, so many questions. Good. I like the questions. Does a compiler implement some optimizations, or must all the optimizations be explicitly in code? Inlining, for example.
So compiler does do best effort optimizations.
Oh,
with
you
the
already
condition with the condition that anything that is sort of not an obviously good optimization. So there's essentially 2 categories of optimizations. There's the ones that are like always obviously good, dead code elimination, constant propagation for like small scalar constants are basically almost always good, and you should always do them. So these are on by default, and really realistically, there's no point in having to control them. There's a second category of optimizations that are not always good and require some kind of heuristic or analysis. These are inlining, these are vectorization, these are loop unrolling. The important thing for Mojo is that the user always has control over these. But, not everyone is a performance engineer. Not everyone is manually unrolling and vectorizing all their loops. So it's important that the compiler default experience is like a best effort attempt to optimize the average Mojo code. But for power users, you can say, turn off the inliner, turn off the vectorizer, or inline in a very specific way, or vectorize in a very specific way. That's kind of the core design philosophy of the language when it comes to compiler optimizations.
Awesome. Most of the time, I I don't spend a lot of time on like low-level programming languages, so I kind of expect compiler to do everything for me, right? But with Mojo, I'm sort of learning to contribute in helping the compiler. But when you write Python code, you don't really think about it, optimizations that much. All right. Do you think
on the flip side, Python will not do any of the optimizations that we mentioned, anyways? So there is no compiler for Python, so it won't even do the always profitable optimizations that Jeff was mentioning, like dead
Mm.
code elimination. If I have an if false, it's still going to evaluate, false and so on.
Yeah, there's this. At least the way I think about it is there's like all the optimizations in the whole world is here, like from a developer point of view, and there's like doing nothing. I think it's not a linear graph. It's like for small things you get huge gains, right, in the beginning, and then it plateaus at some point. But for small things you start getting huge gains, like we see in the stuff that you showed with Mandelbrot and others. Like some basic things will start getting huge gains. At least that's sort of been my takeaway. Do you think it's possible to add C++ interop in both directions? Can Mojo be a carbon? I don't know what carbon is. Carbon
is a successor. Carbon calls itself a successor language to C++ being developed by Google. I mean, you can check out the language. It's pretty cool. It's got a lot of nice features, and I think it sort of dampens a lot of the sharp edges in C++. In terms of two-way interop with C++ and Mojo, the Mojo and C++ type systems are very, very similar. So it is actually in our roadmap to have first-class interop with C++. And first would be in the calling C++ from Mojo direction, but then once you have one direction, it's very easy to build the other one because we understand the ABI differences and how to manage them, how to generate the code to handle that. So it is on our roadmap to have that because that's super important. C++ is, I mean, I write more C++ than Mojo because the compiler is built in C++. So it'd be cool to be able to call into C++ from Mojo and vice versa.
Cool. This is an interesting one. What are the Python features that will be hardest to add to Mojo? Infinitely big ints by default, runtime, metaprogramming.
So I think stuff like maybe eval. That's usually the harder ones. Like eval, you take a string and then you evaluate it and you return a variable. Those things or things that, let's say, I have in Python, the classes are open, so which means I can modify them during execution. So I could say, my class dot foo equals function return 42, and then I can use it. And that's sometimes useful, but that also creates a huge problem. I mean, he creates a huge problem on the compiler side because you can no longer, a lot of things that you take for granted are static are now dynamic, but also creates a huge problem for the maintainability side because I can pass in a class, or I can, one module can just modify some other module's class. And now I have no there is no way of reasoning about anything at that point because it depends on do I, if I import the module first, I get one behavior. If I import it at the end of in the middle of the file, I get different behavior and so on. So it's sometimes not clear how useful these features. I mean, they're useful in special cases, but in the general case, they just are so programmatic, both on the compiler side and also on the understandability and programming side as well.
So for infinitely big integers, Mojo integer literals today are infinitely big. So you can write, 1 with 99 zeros. The trick is that when you use this value at runtime, it gets downcasted to, an int64. But you could write a big int that takes in this raw integer literal in a parameter expression and builds a runtime big int. This just hasn't been built in the standard library yet. For runtime metaprogramming, one reductive mental model for Python is that the language is syntax sugar for hash maps. Classes are a hash map, modules are a hash map, local variables are a hash map, right? Everything is a hash map, functions are a hash map, and so on. And so from that sense, it's actually quite easy to re-implement Python style runtime metaprogramming because all it really is just like changing the keys in a hash map or pulling out a value with a certain key and calling it, passing another thing around. That's actually part of why Python is so powerful and gets all of these crazy features by default because they're all just hash maps. My opinion on what, eval is, you can call it JIT. For me, it's, for example, in Python, you can inspect the current call stack of a function. you can then go to the parents. You can go to the callee, modify local variables in the callee. So you can have a function that when you call it, will just delete all the local variables in the current function. You can actually get the bytecode of a Python function, delete all the branches, and then execute the bytecode. Features like that are in a static language, don't have a bytecode representation, not really like, that's something that probably could never really be implemented.
Well, they're also implementation dependent, because even those programs will have a huge problem running on, the Iron Python and the Jython and all those things as well, right? Which have a different implementation than the C Python implementation. So that's another thing that folks, those. I mean, again, those programs are used in certain pockets. They're not and they're used to like, in some cases, like avoid, like what Jeff was mentioning, like to optimize Python on the fly and so on, which is like, okay, well, you have Mojo, so there's no point of doing that.
I saw a library that was doing static program analysis in Python, and the way it did that, it would execute the code, but it would change the code to execute every branch in every loop once. And it was doing that to like analyze code. That was just super weird. And that kind of thing is, well, in Mojo you would get the MLIR, not the not the bytecode.
Cool. A couple more questions here. I think we'll go through the few of the features that we have, and then we'll spend time on these questions. I will take one question, which is about ModCon. We covered this at the beginning. There's a question about when is ModCon and will it be live stream? ModCon is on December 4th in San Francisco. As to will it be live stream, we are actually working through that right now. We're trying to figure out the logistics on getting that possible. We hope that we'll be able to live stream it, so you'll be able to catch it. But if you can, you should try to be there in person. It's a lot of cool, exciting things happening there, and you get to experience it live. Okay, let's go back to our example. What do we have next? Okay, this is interesting. I think we have there's an enhancement to the benchmark function. If all of you use benchmark or have used benchmark, and we use this in all the sample notebooks, how we benchmark the Matmul notebook and Matmul example and the Mandelbrot example and so on and so forth. So I just pick an example here to demonstrate benchmark. So what I do is I have given a matrix, or given a tensor that's rectangular. What I try to do is like find the average of each row, right? Just for the purpose of this example. So if you want to average each row this way and print out a column vector with all the row values. So there's a function here. I won't go through the code. I'll share this notebook with you. But the key thing I want to highlight is benchmark now has a report function. And when you do report, it prints out the benchmark report. So this is new. So the average time, the total time, number of iterations, warm-up mean, and all of that. So I do this for two different ways to implement this row-wise average. One is naive way, like looping through nested loops. The other is a vectorized and a parallelized way to do this, where I basically have different parallel threads do each row and then vectorize each finding average in each specific row. And this is new. The other thing, so when we do this, I basically compare the speed up, and on my computer this is like a 40 times speed up with my MacBook. But the point of this example was not the speed up, but to show that the new features. Anything else? I know there's another feature. I don't know if anyone wants to, Jeff or Abdul or Jack, if you want to add more color. We changed the way we provide functions to benchmark, right? We changed the
yeah. So how's my mic? Is my mic working all right now?
Yeah, you sound good. Yeah.
Okay, cool. Yeah, so we just made it so that you can pass a function in that captures. So before you had to, like say if you're inside function main, you'd have to have a function closure inside that, and then pass that to benchmark. but now you can just take any function that isn't capturing variables. So you don't have to have like a function from within the same function to benchmark now. So it just makes it a little bit more ergonomic to be able to run benchmarks.
So Jack, are you saying if this was outside of main, I could still, or
Yeah,
okay.
yeah, that's right.
So I don't need to do it this way anymore.
Yeah.
Okay. So this was the old way to do it, and now it could be any function that you provide. Awesome.
right.
Okay. So yeah, okay, cool. So those are the two new updates, and this stuff is pretty cool, right? Benchmark. I'll go to the last feature, and this one is, I don't know, pretty straightforward. Mojo has a SIMD type that's stored directly on the registers, and there are two features here. One is, previously when you want to declare a SIMD type, you had to provide SIMD width this way, right? SIMD, and this could be 1 or 5, whatever, right? System SIMD width. Now if you don't provide anything, by default this is the same width as your CPU's sort of vector register width, which in my case happens to be 4 for single precision, right? When I float 32 now, of course, if I do 64, that would be halved, right? So that value is default now, so you don't need to provide it. So that's one feature. The other feature is you can concatenate to SIMDs. It works, it's fine. I don't know the use case. If anyone wants to share, Jeff or Abdul or Jack, if you know what the use case for the joining SIMD vectors is, then but this feature exists.
So one is we already have a thing called split. So this is a complement. So you can split vectors or slice vectors, I think it's called. So it's useful to like, I split it up. I'm reversing each chunk or something, and I want to join them, stuff like that. It's called slice. Sorry.
Oh, slice.
Yeah. So that's kind of one use case. The other, there's some algorithms that, okay, I need to split up. Again, it comes up again with the context of split. I split up, I pass in the algorithm different chunks, but then I return two new chunks, and now I have to join them together to get the result. So think of, like, let's say a sort function. Within a SIMD, I can split it up, sort the well, I guess sort is not a great example, but let's say let's say is palindrome or something. I can say split, reverse, compare, and so on, stuff like that. These patterns are kind of important.
Cool. Okay, so that was the last feature. I know there are a few others that I didn't discuss. If you head over to the changelog, of course, I didn't also cover the fixes and stuff. So there's these are all the stuff that's here. I just provided you more examples so you could try it out, and we'll share the notebook. This is the benchmark stuff, print. I don't know, all the tensor stuff. Okay, so that's everything, and a few changes too. So I encourage you to go and take a look at changelog and let us know. So we'll do a couple more questions here because I know you all find this super valuable. Okay, dictionaries. I think this is an interesting one. Can you talk about dictionaries? I'm trying to port a Python request that uses dict type in header. What's our, I don't know, do we have a recommended way, I suppose?
So we don't have a dictionary type in Mojo, not yet, but we do have a Python dictionary type in Mojo, which is a Python dictionary. The object type also has a dictionary, but it's limited to object types and stuff. So Python dict typed header. So the simple answer here is we don't have it yet. We don't have dictionaries in Mojo yet, like the proper dictionary syntax and all that stuff.
Cool. Next, does Mojo do memory access pattern optimizations like loop reordering, automatic block sizing?
the compiler does a little bit. So I mean, of course, we use LLVM. So whatever we have on in LLVM will kick in. We do a little bit in our compiler, but so if you're talking about like very complicated polyhedral loop optimizations, that we don't have that yet. And hopefully a lot of these complicated cases are left to the user. We have to evaluate whether or not it's beneficial for the average Mojo code to implement these complicated optimizations, or whether we would leave it up to the library and for people to use them in the performance-sensitive code. There's also a trade-off of compile time. For example, poly is not on by default in Clang because it just takes ages.
Awesome. All right. There's a few more questions. MLIR makes heavy use of lowering passes in Mojo. Do you just imagine that as converting between structs and using reflections? I have to admit, I didn't understand what that means. This is just me. If you want to question too, if you don't mind.
The question is like, what are you trying to achieve? So are you asking like whether or not like you can effectively implement like code, like user-defined code lowerings in Mojo, like on Mojo code?
I don't know if you want to add clarifications, whoever asked the question.
Well, so I can answer a similar sounding question.
Yeah, let's
which is
take your best understanding of the question.
The similar sounding question is, yeah, we will have reflection over the MLIR representation of stuff. That not a lot of details about that yet. And to some degree, right, the way you do a lowering in Mojo is you do like function is, say, let me pick an example, like vector reduce. And then you go, if my hardware, if my type size is this, you call this function. If it's that, you call this other function. So one function will call an MLIR, and another function will call like inline assembly, et cetera, et cetera, et cetera. So the way you basically get lowering via you have lowering via elaboration in Mojo. The role of dialects within Mojo. So in Mojo, you can use any dialects for the most part. The system is not open, right, to the average user right now because there's some complexities around like linking dialects, how to integrate them with the pipeline, like building plugins and stuff like that is very, very complicated. It's not something that we even know how to ship. But the idea is that there's two perspectives. One is that you don't need dialects in Mojo because we have preservation of user-defined information. So you can do transformations directly on function calls. So you can treat like function calls as MLIR operations. You can directly transform them. The other perspective is that actually MLIR dialects add a lot of richness to the ecosystem. There's a lot of complicated logic that you can only really write in as an MLIR dialect. There's a lot of existing MLIR dialects that implement very complicated logic, like the upstream MLIR linalg dialect. And so it's worth being able to tap into this ecosystem and provide that capability. So the answer is there is a role for dialects in Mojo. Obviously, Mojo is built with MLIR dialects. So
cool. This one question we'll take, and I will see if I think Jack has a couple of things to share. Maybe stuff that I missed. This question is interesting because I had the same question. How does that work if you provide a SIMD width higher than the one available on my CPU? Will it crash? Will it be inefficient? So I had the exact same question, and Abdul gave me an answer, which was if you have larger than SIMD width, it'll still be stored on the stack. So the response is the latter. It would be inefficient. So it would still work. It won't crash. You can actually, I think, on my Mac, I was able to save, I don't know, like a 30,000 length vector SIMD, but the answer was it's not recommended to do that. So stick to system width or twice system width because you may have multiple ports. So I do that in the benchmark example too. I do 2x the SIMD width and you get like better speed up. But that's part of the auto tuning process, right? You find what's the best for you. But not recommended to use large SIMD width. That was the response I got. Sound okay, Jeff?
yeah.
And sorry, Abdul had to drop off. So Jack, feel free to. I know you maybe have a couple of samples you wanted to share, stuff that I didn't cover.
Yeah. If you can pop up my screen, I'll just go through a few because we only got 5 minutes left. So I'll just go through the 3 different ones. They're all related to functional programming. with some of the new features that we've released. So this example, you can see it's just performing an operation where it's passing in an operation. So for the first one, it's just going to be squaring 4, so you get 16. And then you can pass in divide, do something like that, and it will divide the number, so you end up with 2. So this is cool because you can actually specify keyword arguments as well to pass through to the operations. So you can do it like this, where you're saying like X is 4 and Y is 2, or the other way around.
So this is new in a 0.5 jack? Is this a new feature?
Yeah, well, in terms of this next one here with keyword arguments.
Okay.
So for parameters. So in this previous one here, like I can't actually check if it's dividing by 0 to throw an error, like a compile time error. But if I do it as parameters, so I put everything in the parameter slot, then I can use this constrain function to check if it's dividing by 0. And then that throws an error saying constraint failed, divide by 0 error. So I think some people get confused about what the difference between parameters and arguments is. So this is like one use case where you can actually check that what you're passing in at compile time is correct. And then another one is, say for like if we had a matrix type, so it's just a standard matrix type that you would have seen before, where we're allocating data. So when I first created it, it's a 5x5 matrix. And then with keyword parameters now, you can actually pass these through to get item. So if I put checked on here and I go outside the range, so I'm going 6, 6, so that's like out of bounds, then you can throw this runtime error. So you can see it down here, it's a runtime error. This has like a little bit of a performance overhead to check for out of bounds. So if you didn't want to use it, you can just turn it off and it works. So Renee. Just dropped my screen. Yeah, so I just want to show those just for some of the cool like functional things you can do, because like in other languages, when you're trying to build like a UI or something, languages have tended to move towards not allowing, like function overloads and not allowing sort of keyword arguments. So it's really hard to do things like build a UI. You got to use like a builder pattern. Whereas this is going to be really nice, I think, for building UIs in the future. So a lot of people have been asking about that. And yeah, as Mojo builds out, I'm sure we're going to get some really cool UI frameworks. So I just wanted to show some of these cool functional features that we have now.
Cool.
Awesome. How many minutes do we have left? A couple of minutes. I don't know. Are there any outstanding questions we can answer? Related to a question about Python plus Mojo code bases for popular libraries. Do modular engineers use any other testing tool beyond built-in testing module when test driving other Mojo modules?
We do have one. Yeah, we have some checks. Like there's a kind of like a testing thing that we have that runs during CI to make sure everything's correct, but that's not in the SDK. So yeah, we might expand our tooling later on to include that in the SDK later.
Cool. Will MLIR syntax in Mojo change once C++ interop is polished?
That's hard to say. I don't anticipate any reason why we'd have to change the MLR syntax. I mean, it's not great, but like it works. So the answer is I'm not sure why it would have to, but if it has to change for one reason other than we can change it, the syntax is relatively flexible. Most people aren't writing MLR ops in Mojo, every day. Yeah,
I try my best not to touch that stuff and use what's in the standard library, right? Awesome. I think that's most of the questions. I guess the questions about other machine learning libraries and stuff, I think people have written very good community projects, built machine learning libraries on top of Mojo. You should check out Jack's newsletter. So he highlights some of these very cool community projects. Other than that, I can say stay tuned. A lot of new stuff we're planning to share in ModCon and in the future. So stay tuned. All right. I think we are at time. We can close. So thank you all for joining us today. And hope you go and try version 0.5 if you haven't already, and a lot of cool new things in the works. So stay tuned for ModCon. Feel free to register. Remember, prices go up on Monday, so if you want to register before Monday, we look forward to seeing you there. There's also the Mojo competition. Head over to Discord and for more information, and check out the newsletters because Jack's newsletters are where you can find all the modular as well as community updates.
And
all
also
right.
just
Any
this
final-
one other, yeah, just one other thing. I can see Vilson in the chat. He's the one who created Awesome Mojo. So that's a GitHub repo where you check all the other, like all the projects that are getting released. So he keeps that updated pretty regularly. So definitely check out Awesome Mojo if you get a chance. It's really cool.
I love that. So Wilson, thank you for doing that, because I go to that quite often. It's really cool, and I think I should just before we close, I should just show folks. So this is the one, right? Is this the one? Or this is not the one?
Just scroll down a bit.
Or maybe the look and feel has changed a little bit.
No, this is
not this one, right? I remember. Oh, this one, Magicians. Yes, this is the one.
Yeah,
Magicians.
I love this. This all the popular projects are here. I go to this quite often, and I highly recommend you all go check this out. It's a super cool repository of popular projects.
Oh, and speaking of which, if anyone's here is working on that stdlib extensions library, I've seen the bugs on like importing from a module that has the same name as the current file. Like we know that's a big issue, and we're working on that. Yeah, so it's like there's like maybe like 5 or 6 issues, and they crash in like 7, 8 different ways. But yeah, we know that's a problem, and we know that people are trying to build a stdlib extensions thing where they just have the same modules, the same name as one's in the center library, and it's causing things to explode. So yeah, we know that's a problem. We're working on a fix.
Awesome. All right. We're at time. We'll close. But we'll see. We'll keep tuning into these. We'll see you in the next edition. So subscribe to YouTube and follow us on LinkedIn and all that, so you'll know when the next one is. With that, thank you, everyone. Thanks. Bye.
Cheers. Bye.
See ya.